Welcome to Mr. Benjamin's Math World. Today we are going to be working with how to factor perfect square trinomials. But first we need to define what a perfect square trinomial is. When factoring perfect square trinomials, there's a very important term we need to remember. This term is square root. Let's remember. The square root of 25 is 5 because 5 times 5 is 25. The square root of 81 is 9 because 9 times 9 is 81. The square root of x to the second power is x because x times x is x to the second. The square root of x to the fourth is x to the second because x to the second times x to the second is x to the fourth. But let me stop right here and let me show you what I'm doing. X to the fourth power, the square root is x to the second power because x to the second times x to the second equals, remember we're multiplying monomials, we multiply the coefficients, 1 times 1 is 1, omitted, we put the x and we add the exponents. 2 plus 2 is 4. This is because 2 plus 2 is 4, not because 2 times 2 is 4. No, in this case, we get the same result, but that's not the way it is. Example, x to the 8th, the square root of x to the 8th is x to the 4th, because x to the 4th times x to the 4th equals 1 times 1 is 1, x 4 plus 4 is 8. Because we're multiplying monomials, we add exponents. So this is adding, not multiplying 4 times 4, but adding 4 plus 4. Once we remember the square roots of coefficients and variables, we can proceed. We were in the definition of a perfect square trinomial. Number 1, it has to be a trinomial. 3 terms. 1 term, 2 terms, and 3 terms. Condition number 1. Condition number 2. The first term has to be square. It means the first term has to have square root. The square root of x to the second, as we know, is x. It's right here. Second condition. The third term must also have square root. The square root of 16 is 4 because 4 times 4 is 16. Let me put the 4 down here. I'm just showing the square roots. We don't need to do this. And the third condition, and most important, the second term must be always 2 times the square root of the first term, which is x, times the square root of the third term, which is 4. 2 times 6 times 4 is 8x. What have we done? We have just gotten to the conclusion that this trinomial is a perfect square trinomial. Let me repeat that. The first term has square root. The third term has square root. So far it is perfect. The third condition. What about the second term? Oh, the second term must be equals to 2 times. This does not vary. This is always 2 times. 2 times the square root of the first times the square root of the third, which is 8x. Here it is. Now we know that it is a perfect square trinomial. One thing is to know that it is a perfect square trinomial, and another thing is how to factor that trinomial, which is our next step. I'm erasing this because now we know that it is a perfect square trinomial. How do we factor a perfect square trinomial? Like this. X to the second plus 8x plus 16 equals, open parenthesis, the square root of the first term, which is x. The sign of the second term, positive. The square root of the third term, which is 4. Close parenthesis, to the second power. Finished. When factoring x to the second plus 8x plus 16 equals x to the 4 to the second power. What does this mean? This means that if you multiply x plus 4 times itself 2 times, the result must be the same square trinomial. How can we prove that? We can prove it by using the FOIL method, which is one of our topics in previous videos. In order to prove that this is correct, this factoring is correct, in order to prove it, let's use the FOIL method. X plus 4 times x plus 4, because x plus 4 to the second is equals to x plus 4 one time times x plus 4 another time, which is 2 times. Now let's multiply this. Again, the FOIL method. I'm not going to explain it again because we saw the FOIL method in previous videos. X times x, x to the second power. X times 4 plus 4x. Plus 4 times x plus 4x. Plus 4 times positive 4, positive 16. Equals. Like terms, these two. Bring down the x to the second. 4x plus 4x, positive 8x plus 16. It means that this factoring is correct. Let's see our second trinomial. We got a trinomial right here and we need to factor it. Our first step is just to know what kind of trinomial it is. It is perfect or non-perfect. Obviously, if it's a perfect trinomial, it's not a non-perfect. There are some considerations about that, but let's see if it's a perfect square trinomial. Condition number 1, the first term should have or must have square root. Does it have square root? X to the second has square root? Yes, it's x. So far, it's a perfect square trinomial. The third term also has square root. The square root of 25 is 5, because 5 times 5 is 25. What about the second term? Okay, the second term is equals to 2 times the square root of the first term, which is x, 2 times x, 2x, times the square root of the third term, which is 5. 2x times 5 is 10x. It's right here. Now we know that it's a perfect square trinomial, and now we can factor it as such. How do we factor it? Again, open parenthesis, square root of the first term, sine of the second term, square root of the third term, which is 5, close parenthesis to the second power. Here it is. It is already solved. Now, if you need to make sure, if you want to make sure that this factoring tells you the truth, that it is correct, use the FOIL method. Because the FOIL method multiplies two binomials. So I'll be multiplying x minus 5 times x minus 5 equals FOIL method again. X times x, x to the second power. X times negative 5 is negative 5x. Negative 5 times x is equals to negative 5x. And negative 5 times negative 5 is positive 25. Any like terms? Yes, these two. Bring down the x to the second. Negative 5x minus 5x. Remembering the rule, when two numbers have the same signs, we add the numbers and we copy the same sign. This is adding and subtracting. This is not multiplication. So I'm using the rules of signs in addition and subtraction. Two numbers have the same signs. I'm going to add the numbers and I'm going to copy the same sign, which is a negative sign. So x to the second negative, 5 and 5 is 10x. And bring down the plus 25. Did I get the same trinomial? Yes, I did. It means that our factoring is correct. And this is the way we factor a perfect square trinomial. If you think this was a useful video to you, please feel free to subscribe and activate the bell in order to receive further notifications. See you next time.